got to start. I stopped it. Okay, so let me just say this one more time because I just started the video. Sorry, my apologies. So infinite limits. So we're trying to find the limit of natural log x when x approaches 0 from the right. So one thing I said always from the beginning, x approaches 0, meaning x not equals 0. But now, with number 2, I'm contradicting number 1, and I'll explain why. So when I'm looking at a limit, I don't know what type it is. There are many types of limits. And please understand it, try to understand the concept of the limit, because you will never get rid of it, ever. Not in Calc 1, not in Calc 2, not in Calc 3. So the concept of a limit is huge. So now I'm contradicting myself with this. So I'm contradicting 1 with 2, saying must plug in to identify the type of a limit, of the limit we are facing. In certain situations, plugging in will give us the answer. And again, you can say, and I will have to agree, you just told us not to plug it in. True. But this is required every time we determine a limit, because there are different categories and we don't know what category this is before we plug it in. So when I plug it in, contradicting my number 1, I say, oops, let me graph my function. And when I graph my function natural log, which by the way has to be always active in your mind, this is natural log x, this is x equals 0, which is the vertical asymptote. I will say this is undefined. If I want to plug in 0, natural log 0 does not exist. You cannot plug in 0 in any log of any base. So keeping in mind that this is the graph, I will immediately say negative infinity, and I will write x equals 0, I already wrote it here, is a vertical asymptote. So why is this called an infinite limit? Is because the answer is either positive infinity or negative infinity. So it's called an infinite limit. Here's another example. I'm looking at problem 31 from 2.2. So we have limit as x approaches 2 from x squared over x minus 2, everything squared. Now we need a very important note here, so please remember in moving forward. When I plug in 2, because I have to only to identify the type of limit, and there are certain situations in which the answer will be just that, answer that we get. But when I plug in 2 here, I get 4 over 0. 4 over 0. So you can say it's D and E. It's undefined. Why don't I write D and E? I can't. Because the limit is determined when x approaches 2 from either side. Note, when we calculate limit from either side, and we get something like this, I'll put in parentheses, whatever not 0 over 0, in this situation, we must determine both limit from the left and limit from the right of f of x, of course. We cannot draw a conclusion. If I get a number over 0, if I get 4 over 10, it's 2/5 and I'm done. I don't have to do anything. But if I get a number over 0, I must determine both sides. Okay. Because otherwise I will be tempted to write the wrong answer. Okay. So we have limit as x approaches 2 from the left. You could say, and I would have to agree with you, why are you even bothering, because this is always positive. If you notice that, you know the answer is infinity, and you're done. But let's say we don't notice that. We overlook that. So 2 from the left of x squared over x minus 2 squared, the numerator is 4, the denominator is 0, but I want to replace x with a number from the left smaller than 2. I'm replacing it with 1.9. Because of this symbol, I have to be from the left of 2. The numerator is still whatever, close to 4. But now the denominator is 1.9 minus 2, which is a negative number. I square that number. So the numerator is positive, the denominator is positive. I know the answer is infinity. In the same way, I will determine the limit as x approaches 2 from the right, from x squared over x minus 2 squared. It happens to be the same thing. So therefore, I cannot write d and e. Because both sides go to infinity, I must write infinity. If I have only the left or the right limit, I don't have to do all this. But if I have either side and I get a situation of 4 over 0, it could be d and e, it could be infinity, it could be negative infinity, I don't know. I have to calculate both limits, from the left and from the right. In general, I like to discuss one other note here before I move on to the next example. Note. A number over 0, obviously this is not 0. Has no hope. So the limit of this situation with a number over 0, let's say x equals a from f of x, could be infinity, could be negative infinity, or could be d and e. It will never exist, no matter what we do. Such a limit of a number over 0 will never exist. However, I think I'm on 7. Am I on 7? Yes.
Yes.
Thank you. However, 0 over 0 has hope. I'm not saying the limit exists. No. I'm only saying that there is hope. But a number over 0, there is absolutely no hope ever to exist. Any questions so far? Any questions so far?
No.
Okay, so let's take a look at that. I think I only have 2 questions on that before we continue with the next section on limit laws. And one of my computers is hibernating, so I need a second to wake it up. So let's go back and see if we can do our, yes, I'm still here. It says, are you still there? Yes, I am. Oh, of course I have to sign in. Nice. Okay, so let's take a look. So let's look at 2.2, the limit of a function. I only put in there 2 questions. So let's see what we can work on. I would like to start with problem 2. And if you'd like a similar problem first, I'll be more than happy to show a similar problem first. Let's do just that. So let me show a similar problem. Here it is. Find the vertical asymptotes of this function. So let's do that before we look at the quiz and we work on it together. So problem 41 on 2.2. So we have the function f of x, which is x minus 1 divided by 2x plus 4. Oh no, I wanted 42, I'm sorry, which is a little bit more complicated. I don't want this. So x squared plus 1 over 3x minus 2x squared. 41 is too easy. You can do that on your own. Okay, so here we are asked to find the horizontal asymptotes. Well, the correct answer is only the asymptotes is not good enough. We also have to determine the limits pertaining to those asymptotes. 1 second, get a glass sip of water. So finding the asymptotes is not enough. Okay, so I see the numerator is x squared plus 1. I don't like this arrangement. I like this arrangement in descending order. And I will factor out negative x. And I get 2x minus 3. And I will rewrite with minus in front. I don't care for that minus. It doesn't mean anything, really. So at some point, at this point, I will ask you, for which x values is this function undefined? And you will immediately say, for x equals and for x equals. Great job. Now, careful with the vertical asymptotes. Very important. Note.
How do you get those two answers?
By setting the denominator not equal to 0. The denominator of any function cannot be 0 because otherwise the function is undefined. So then from x equals 0 we get this, and from 2x minus 3 we get that. Is that everyone okay? Is everyone okay with this?
Yes, thank you.
Thank you. Okay. So, no. Let's look at this example. So I have a function, I'm going to call it g of x, 2x minus 1 over 2x minus 1 over x plus, times x plus 3. From here, I know that x cannot be 1/2 and x cannot be negative 3. Are we in agreement with this?
Yes.
However, after I state the restrictions, they are called the restrictions. We wrote that before on x. I'm allowed to simplify, not before I state restrictions. 1 and 1. So the simplified form of this rational function is 1 over x plus 3. This point will create a hole in the graph. And only x equals negative 3 will be a vertical asymptote. So careful with that. If a factor from the top cancels with the factor from the denominator, the function is still undefined at that point. However, after you simplify, that x equals 1/2 will not be a vertical asymptote, will not create a vertical asymptote because the factor disappears. Only the factor that stays forever in the function after simplification will create a vertical asymptote. We're going to come back to this in chapter 4, but I want you to be aware of this situation. So this is a very important note. if the factor disappears. So for example, here if I had an x in front, I would have simplified x with x after stating the restriction, of course, that x cannot be 0 and x cannot be 3/2. And x equals 0 would have been a hole in the graph, but only x equals 3/2 would have been a vertical asymptote. But there is no factor of x, there is no factor of 2x minus 3. Both of them are vertical asymptotes. This is good, but it's not good enough. We have to determine the limits left and right for both. Left of 0, right of 0, left of 3/2, right of 3/2. And that is the complete answer to the problem. So let's continue and find those limits. So limit as x approaches 0 from the left, from negative x squared plus 1 over x times 2x minus 3. You know I plug it in because I need to see what type it is. The numerator is 1. Negative 1, it doesn't matter because I'm going to take that into account anyway in a minute. And the denominator is 0. I know that this limit has no hope. Of course, it cannot have any hope because it's a vertical asymptote. So the answers could be infinity, negative infinity, or dne. So now I plug in 0 from the left, like negative 0.1. But it doesn't make any difference here. It's still negative 1. With negative 0.1, this is negative 0.2 minus 3, negative, and negative, so the denominator is positive. If the numerator is negative, the denominator is positive because this is negative, negative 0.1, and this is negative, it's positive, so I know that this is negative infinity. In the same way, I determine the limit as x approaches 0 from the right of negative x squared plus 1 over x to x minus 3. And let's see what we get. And again, the numerator is still negative 1. The denominator, this is positive. This is still this is negative though, because positive 0.1 minus 3 would be negative. So in this case, this is infinity. So we know the behavior of the function left and right of 0. In the same way, we will determine the limits for 3/2. So limit as x approaches 3/2 from the left, and then limit as x approaches 3/2 from the right. Of the whole thing, the same thing. So of negative x squared plus 1 over x 2x minus 3, negative x squared plus 1 over x 2x minus 3. Okay, so let's see what we get. Now, with 3/2 left and right, I don't care. This is a positive number. This is a positive number. So let's see what we get. A negative at the top. And 3/2 smaller than 3/2 is like 1.4. 2 times 1.4 will be lower than this. I mean, negative 3 will overcome it. So it's negative. So the answer is positive infinity. Now the top, it's still negative. Now this is 1.6. But 2 times 1.6 minus 3 will be positive. So this is negative infinity. So it's not sufficient to say, oh yeah, x equals 0 is a vertical asymptote. No. Now we know how to determine infinite limits. So we determine the limit from the left of 0, the limit from the right of 0, and the limit from left and right of 3/2. So now we are ready to, we don't have to do anything because I did the problem for you. So that was the same function. Okay, so let's work on problem 1 then. Let's take a moment.
How do you note it in in Canvas for the answer?
The vertical asymptote is 0, comma 3/2. 0, comma 3/2 with a slash. I'll choose 2 more problems for you to work on by Monday. Okay, let's work on the first one, and then we can start